Say it again. Any questions here?
Can you just leave that up for like 5 minutes?
Okay. So let's look at problem 149 on page 169. I'm reading it while in the meantime you're copying that. A pool measuring 10 meters by 20 meters. Any questions? So here's a pool. It measures 10 by 20. It's surrounded by a path of uniform width. So surrounded by a path. Of uniform width. And we will call that width x. If the area of the pool and the path combined is 600 square meters, so the whole area, whole thing, total area, 600 square meters. They're asking us to find the width of the path. They're asking us to find x. Okay, so let's go back to this and I'll explain the problem one more time. Do we have any questions on these?
No.
Everything okay? Awesome. So here's our scenario. We have a pool that is 10 by 20, length 20, width 10. And we have a path we construct, or we build a path around it that has a width of x. We don't know. But what we do know is that entire area of the whole thing, the pool and its path around it, of uniform or equal width, is 600 square meters. Since it is a rectangle, can anyone give us the area of the rectangle? Say it again. Yes? Very good. Of course, length times the width. So we are given an area of 600 square meters. Can anyone identify the length for us? This is the length, and this is the width.
So the length is 20.
This is 20. This is not 20. Yes? So 20 plus 2x indeed. So the length is 20 plus 2x. X plus 20 plus x. Awesome. Can anyone identify the width for us? So we have to multiply it here. Yes? Plus 2x, of course. So the width now has this x, has 10 and another x. X plus x is 2x, and the rest is 10. Excellent. Good. We are asked to solve for x. Now we look at this situation, we identify what type of equation it is, and then we proceed. What type of equation is it? We only reviewed 3 types. Linear, quadratic, rational. Quadratic, very good. So let's FOIL. We have no choice. So the left-hand side is 600. It doesn't matter where you want to start. I'm going to start from 10. 10 times 20, 200 plus 10 times 2x, 20x plus 2x times 20, 40x, very good. And 2x times 2x plus 4x squared. Good. Any questions so far? All we did was we created an equation that represents the area of the whole thing, pool plus the surrounding path. And now, knowing that this is quadratic, we started by foiling, and now we do what? I'm looking at this equation, and where do I start? Combine like terms, you arrange it in descending order, and set it equal to 0. So then we have 4x squared plus 60x minus 400 equals 0. So 4x squared, we combined 20 with 40, we got 60. We had to bring 600 back, but it becomes negative. Negative 600 plus 200 is negative 400. Okay, it's in descending order, it's nice, but I can simplify it. I will always do that. So how do I simplify it and how? Yes? We will have to divide everything by 4. Awesome. Thank you. So this is x squared plus 15x minus 100 equals 0. We have 4 methods. Which one would you think of? No one indicates you which method to use. No, it's a word problem. No one forces you to use a particular method. So can anyone tell us which one would you think of? Yes, but when I see 100 in there, quadratic formula, that's the easiest. That's the point I'm making. If it takes you 10, 15 seconds to factor, otherwise. Okay, so negative b plus or minus b squared minus 4ac over 2a. I also would like to show you how to do this with the graphing calculator if you allow me. So with the graphing calculator, before I do this, I just want to explain. If we put everything in the graphing calculator, I highly recommend parentheses around the number under the square root, and also mandatory. This is recommended, but this is mandatory around the numerator. If there are operations in the denominator, I will put the denominator in parentheses as well, but there is no need right now. So please pay attention. So left-hand side, the numerator left parenthesis, and then we have negative 15. This is the negative. This is the operational negative minus, but this is the negative, negative 15 plus. You cannot put plus or minus in the calculator. This is not what I meant. I want the square root. I put parentheses because I'm old-fashioned. The newer calculators may not need parentheses, but I still recommend those. 225 plus 400. Close the parenthesis. Go outside, close the parenthesis, and divide by 2. And the answer is 5. I want to find the other solution with minus. So go to second and entry, copy the whole thing one more time, and just go over the plus and override it into a minus. It's easier with the calculator than with the software. So I put minus, and I press enter, and I get minus 20. So the equation has 2 solutions. X equals 5 meters, and x equals negative 20 meters. Since we're talking about meters, what will you say? You will say no way, and you will say yes. So the width of the path around the pool is 5 meters. Any questions? This was an application, so you see why we study quadratic equations and modeling with quadratic equations. Any questions for me? Okay, other types of equations is the next section, which is 1.6. So let me just refresh your memory. For this weekend, you have to be finished, please, with factoring. I'm reviewing everything from the very beginning. Factoring assignment in my math lab. 1.1, 1.2. We had 1.5, and whatever we can do from 1.6. But at least these have to be done. Your last chance for a grade as of now. Okay, other types of equations. 1.6. There are many more. So how many we know so far? We're going to add to the list. We know linear. Yes, we know rational. And we know quadratic. We're going to add polynomial, radical. So 1, 2, with rational exponents, equations with rational exponents, absolute value equations. We're going to add equations quadratic in form, not quadratic, quadratic in form. Later on, we are going to add exponential in a different chapter. I swallowed something. Exponential, log equations. But that's for later, not in this chapter. And that will be the end of it. So now let's go through whatever we can from here. So let's start with polynomial. And I expect you to say, wait a minute, what are you talking about polynomial? What about linear and quadratic? What are they? Aren't they polynomial? Yes, they are. But when we talk about polynomial, we don't mean linear. We don't mean quadratic. We mean higher degree. Degree 3 or more. This is what we know, or what we refer to polynomial equations. When we talk about linear, it's linear. When we talk about quadratic, it's quadratic. But this is higher degree. If you'd like to choose, we are on page 185. If not, I will. And the first set is between 1 and 10. So we're talking about polynomial equations. You want to choose? Go ahead. If not, I will. 1, 2, 3. Number 4. On page 185. And we have 4x cubed minus 12x squared equals 9x minus 27. So we go back to what we know from factoring, and we will identify this is what type of equation. What type is it? It's right here, right? So there is no discussion. It has degree 3, right? It cannot be linear. It cannot be quadratic because it's degree 3. It cannot be rational. It doesn't have x in the denominator. How many solutions are we after forever, always? Exactly the degree. In linear, we were after 1. In quadratic, we were after 2. In cubic or degree 3, we are after
3.
Exactly 3. Good. What will you do? What do you recommend?
Move everything over.
Oh, of course. So 4x cubed minus 12x squared minus 9x plus 27 equals 0. Now I dig deep and I ask myself, what type of polynomial is it? Exactly. And my only chance is by? Exactly. There is no other way. But I still have to ask myself, after polynomial, is it in descending order?
Yeah.
Greatest common factor?
No.
Negative leading coefficient? Good. So we are on. From the first two.
3x.
4x squared. What is left in parentheses?
Excellent. 3.
Awesome. What do I have to have from the other two?
Excellent.
Otherwise, I can't continue. And now we cannot fabricate it. It has to be there. So now I need sign and factor. Excellent. What is the common factor that gets pulled out now?
X minus
Indeed. And what is left in parentheses?
4x.
How do I factor 4x squared minus 9? You see why I went to factoring supplement first.
2x plus 3.
Awesome. How many solutions again?
3.
Of course. The degree is 3. We have to get 3 solutions. Even if they're all the same, it doesn't matter.
First one's x equals 3.
Awesome. From the first factor, we get x equals 3. Great job. From the second factor, what do we get? Yes, 3 halves. Perfect. And from the last factor, 3 over 2. Do we all agree with these answers? Do we have questions, please? Please ask anything. I don't want you to fall behind. Is this okay?
Yes.
It's a lot of work, I agree. Do we need another example with polynomial? Or we move on to radical? Another one? Very good. Let's look at problem 10. Same page, 185. 3x to the fourth equals 81x. Okay, I have to ask myself what type of equation is this. Now I know 4 types. I know linear, I know quadratic, I know rational, and I know polynomial. Which one is it? Which one is it? Is it linear? Is it quadratic?
No.
Is it rational?
Both.
Polynomial. Good. What is its degree? How many solutions do I have to find? Indeed. Awesome. Well done. Good. But I'm into simplifying first. And you cannot divide by x. But you can divide by? We can divide by? Indeed. Good. Awesome. So then we have x to the fourth equals 27x. We divided both sides by 3. Now what? Exactly what we did before. I cannot factor if I have something on one side and factor and something on the other.
Yes.
Correct. So x to the fourth minus 27x equals 0. It's what type of polynomial? Binomial, indeed. Is it in descending order?
Yeah.
Greatest common factor that I could not get rid of. Very good. What is left in parentheses?
X cubed minus 27.
Very good. Awesome. Now we have to dig deep. How do I factor x cubed minus 27? Yes,
Would that be, wait, isn't 3 cubed 27?
correct. So which special product is applicable here? The difference of
Cubes.
perfect. And when you say the difference of cubes, what will you get ready? This times this. What is this?
Oh, by
Times? Indeed. That's why we factored first last week. Very good. X minus 3, I agree. Remember, if we factor the difference, this has the difference. What do I have in the middle?
addition.
Very good. And the last one, there is no discussion there ever. Good. So, yes. Awesome. This formula does not have that too. It's just the product. Just the product. X times 3. Plus, that's it. Good. Remember, we expect. Good. Can you already give 2 of those? Yes? Yes. But the other 2 you can't just yet. We have to write x squared plus 3x plus 9 equals 0. How many solutions will we get out of this one? Exactly, 2 more. 1, 2, and 2 more from here. We'll have 4. Good. What am I doing now? I have 4 methods. I have factoring available. I have taken square roots. I have completed the square, and I have quadratic formula. It's not factorable. Factoring doesn't work here. Of course. Quadratic formula. So then x equals negative b plus or minus b squared minus 4ac over 2a.
Isn't it negative 3 plus or minus the square root of
The square root of negative 27. Yes, yes. Let's write that. So x equals negative 3 plus or minus the square root of negative 27 divided by 2. But I have to work on negative, yes, plus or minus the square root of negative 1, the square root of 3, and the square root of 9. How much is this?
3?
How much is this? Very good. So finally, negative 3 plus or minus 3i, the square root of 3 over 2. We got 2 solutions and 2 more. A total of 4. Any questions? Okay, we're down to 3 minutes. I just want to show you the second one, just one example, and we'll stop. Radical equations. Radical equations. Very simple example, number 12. The square root of 20 minus 8x equals x. Indeed, we have to square both sides. When we square the left-hand side, what do we get? When we square the right-hand side, what do we get? Good. What type of equation is it?
Radical.
What type of equation is this?
Well, we knew everything was
True, but what type is it? It's quadratic, so it's x squared plus 8x minus 20 equals 0. The numbers are small enough. I can use factoring. So x plus 10 and x minus 2. So we have 2 options here. What is this? That's my last page. Okay. So we have one option which is negative 10 and another option which is 2. We have to check back in the original problem. The square root of 20 minus 8x equals x. I'll explain more next time, but we have to check. So negative 8 times negative 10 is 80 plus 20 is 100. The square root of 100 is 10, but the other side is negative 10, so it cannot be acceptable. For 2, 20 minus 16 is 4. Square root of 4 is 2. I will say yes. I still have 1 minute. I see you're packed, okay? But I still have 1 more minute. And I want to take attendance.